More Industries presents an STA safety trip alarm demo with Peter Welander.
Hello, Peter Welander here, and today we're going to look at the safety trip alarm, or STA, from Moore Industries. This is part of Moore's ongoing line of instrumentation and safety devices going back more than 40 years. If you spend any time in a manufacturing environment, you know the importance of safety systems and how companies are following standards like ANSI ISA 84 and IEC 61508 and 61511 as they design safety strategies. Safety instrumented functions are designed to move a process to a safe state should there be a hazardous event that the normal control system can't handle. The STA is a standalone safety system logic solver, which means that it has some of the same functions as a PLC, but it is certified to work in a safety instrumented system, or SIS. It is easier to use and significantly more affordable than a typical PLC, and can work as an extension of a larger control system or perform localized operations. It has been subjected to critical testing by TUV and Exida and approved for 61508, 61511 compliance, including single-use and safety instrumented systems up to SIL 2, with firmware approved for use in SIL 3 systems. The situation in your plant will have to be evaluated by a certified safety engineer who can put it all in the correct context. The functionality of the STA is pretty simple. It's designed to support a single sensor that trips a relay when a process has passed its safe operating point. The sensor can measure any appropriate variable, such as level, temperature, or pressure. It has two alarm points, high and low, plus an alarm for an internal or system fault. Let's take a look at an actual unit in a simulated application for an example. Here's our setup. Let's say this little hot pot is our process. Our sensor is a 4-wire RTD, and we're measuring temperature in degrees Celsius. We want the liquid in the tank to be higher than 20 degrees, but below 70 degrees. So we've set the low alarm at 25 and the high alarm at 65. We've connected the alarm relays to the annunciator in the control room there on the left. There's a third possibility that something will go wrong with the hardware, so we also have the fault alarm. With our process running, we find things are getting out of control and the temperature is rising fast. Once it passes 65 degrees, there's a 5-second delay before the relay trips. The delay, along with the alarm temperature, can be set to suit the application. The light in the control room turns on once the alarm is tripped. Let's say the alarm turns off the heater once it is tripped, and the temperature begins to go down. We've set a deadband of 5 degrees, so the temperature will have to go down to 60 before the alarm releases. We could also set it so the alarm can only be reset manually. The light goes off when the alarm resets. If we go to the opposite extreme by adding some ice, the temperature goes down until it hits the low alarm at 25 degrees. Again, we've programmed a 5-second delay and a 5-degree deadband, although each alarm can have its own setting. In this case, the green light on the annunciator says that it's something that we aren't particularly concerned with, but it is something that we want the operators to be aware of. If we turn the heater back on and reverse the temperature direction, it will go back up, passing the alarm point at 25, but it won't reset until it hits the deadband at 30 degrees. If we have a stable process, but find that something in the safety system is damaged, like disconnecting a lead from the RTD, the fault relay trips and the diagnostic capabilities even describe what has gone wrong. In this case, it knows there's a broken wire from the sensor. The fact that the 3 alarm relays operate independently gives you the flexibility to determine how they interact. If high integrity is your main objective, all 3 can be connected in series so that a trip of any one of them will trip the circuit and take the process to a safe state. If high availability is more important, you can wire the fault relay to a separate monitoring device like a PLC that initiates personnel intervention but doesn't immediately trip a critical or expensive batch process. All variables are user-defined, from the type of sensor, measuring range, alarm points, delay time, trimming, analog output, and so on. So let's review our demonstration. The STA is a standalone logic solver designed to perform one or more safety functions working with a single sensor. It can support 2 process alarm points, plus has a fault relay that detects internal or system faults. It includes an analog output that can be used to retransmit the PV to a third-party monitoring system or device. Process alarm trips and analog outputs are user configurable via an intuitive programming menu accessed by front panel push buttons. It's certified by third parties for use in safety applications by TÜV and STA, and it's an economical alternative and easier to program than more expensive safety PLCs. Take a look at the STA as you evaluate your safety instrumented system. Detailed information is available for the STA and all of Moore Industries products for temperature measurement, signal interfacing, conditioning, networking, field device transmitters, and field bus networks. See them all at Moore Industries' website. Go to miinet.com. That's miinet.com. This is Peter Welander. Thanks for watching. Copyright 2012, Moore Industries International, Incorporated.